Metals and non-metals. Corrosion. When I say corrosion, the first things probably that come in your mind would be something like this. You would have seen a lot of this silverware in your house that lost color over time. You might remember certain monuments that gained some other color over time. And you would have seen a lot of metals which have this kind of appearance where it is reddish brown in color after a point of time. All these are examples of corrosion. So what exactly is corrosion? Corrosion is a natural process that converts a refined metal into a more chemically stable form, such as oxide, hydroxide, or sulfide. Okay, so this is the definition of corrosion. To understand this better, we will take three precise examples. Okay, the first one, look at the picture where you have the spoon handle. Okay, you can see that the first one is nice, bright and shiny, but it becomes a little dull. Then it becomes black over a time. So why does it become black? Because of corrosion. Yes, that is obvious. But chemically, what is happening? Silver particles react with sulfur in the air to form a coating of silver sulfide. In this case, corrosion happens with the formation of silver sulfide, which is chemically more stable than silver in your silver plate or silver spoon or your silverware. Okay? The next example, look at the Statue of Liberty on your right. You can see that the statue in 1886 was shiny copper gold, but around 2018 you can see that it is mild green in color. So what happened over time? Corrosion happened, correct. But chemically what happened? Copper reacts with moist carbon dioxide in the air, forming basic copper carbonate. Copper carbonate is chemically more stable than copper and it has a greenish appearance, which is what you see on the statue. Look at the last example, which is the most common type. Okay, you can see that on the right side of that picture, everything is shiny and bright, but it looks reddish brown on the left. That's because of corrosion. But what happened chemically? Iron, when exposed to moist air, gets rusted. So the formation of rust is corrosion. Okay, so this is the entire explanation of corrosion, and by now you will know that corrosion means a metal transforming to a stabler form with exposure. Okay, so what we will do now is we will do an activity 3.14 where we will be experimenting with iron nails in different conditions to study its chemical response. Okay, iron nails, iron is a metal. Okay, so that is the example we will take in this experiment. Okay, so we'll have an experimental setup first. So what is the setup? Let's see the procedure. We will take the iron nails in three different conditions, A, B and C. Okay, so what are we doing in these three conditions? First one, the iron is dipped in water. The second one, B, nail is dipped in water with some oil floating on water to prevent the air from dissolving in the water. The last one, we will have iron nail with anhydrous calcium chloride to absorb the moisture, if any, from the air. So now from the procedure you can see that three different test tubes are maintained at three different conditions with iron nails in it. So what exactly is the condition over here? You can see in test tube A, in the diagram also you can see that the iron nail over here is exposed to water and air in the test tube. Okay, it is also corked at the top so that there is constant air and water also inside. In the second condition, the nails are exposed to water and not air. Why? Because water and oil are immiscible. Immiscible means they don't dissolve each other. Okay, so the oil on top makes a layer between the water and air. So the nails is there only in water. As an additional measure, okay, the water will also be boiled in distilled water so that there is no dissolved air also. Okay, and that layer prevents the air from top to dissolve into the water. So the nails are exposed to only water in the second condition. In the third condition, we have a drying agent called anhydrous calcium chloride. Anhydrous calcium chloride is called a drying agent because it absorbs the moisture from the air. Okay, so now you have three different conditions. A has water and air exposure. B has water exposure only. C has air exposure only. Now our experiment is to see how the nail reacts to each of this setup. Okay, so if you did this, your observations would be that the nails in test tube A got rusted in a few days, but the nails in test tube B and C did not get rust. Okay, so how can we infer what happened? In test tube A, the nails were exposed to both air and water. Okay, in test tube B, the nails were exposed to only water, and nails in test tube C are exposed to only air. Okay, so the test tube A, which is the setup where the nails were exposed to both air and water, got rusted, right? So that is the inference of this experiment. Okay, the inference is air and moisture is required for nails to rust.